let's look at some word problems involving proportions and similar figures. We begin with this problem which says a serving of 8 crackers has 400 grams of sodium. I'm going to write that as 400 grams goes along with 8 crackers, and I'll abbreviate that CR. The question first is, how much sodium is in 14 crackers? Well, this was a given rate, and I can set rates equal to each other in a proportion. I want to know how many grams are in 14 crackers. I really think it's a good idea to write your units down because you want to line up the units horizontally with respect to each other so that you don't accidentally get the second fraction reversed. That's where most people have their trouble. Now I'm going to reduce this first fraction. 400 divided by 8 is 50. So I'm going to have 50 over 1. And basically that means there's 50 grams of sodium in each one cracker. And I can now say and solve this problem by cross-multiplying. 1 times x is 1x. And the other diagonal is 50 times 14, which is going to be 700. So I have x is equal to 700 grams in 14 crackers. Now we have a second part to this problem. If the FDA suggests a maximum of 2,300 grams of sodium per day, how much more sodium can Bill get from other foods if he eats 18 crackers? Well, we already know that 400 grams of sodium are contained in 8 crackers. And we've also reduced that in part A to 50 grams of sodium in 1 cracker. We need to find out how many grams of sodium there will be in 18 crackers so that we have our units lined up. Now we're going to solve this by cross-multiplying. One diagonal is 1 times x, which is just x. The other diagonal is 50 times 18, which is 900. So that says he is going to consume 900 grams of sodium from these 18 crackers. The question then becomes, how much more sodium can Bill consume from other foods if he's had these 18 crackers already? So we will begin with the 2,300 grams that he is allowed per day according to the FDA and subtract off the 900 grams that he's consumed already and find out that he has 1,400 or 1,400 grams of sodium that he can consume from other sources. In this next problem, we are asked to compare distances on a map to actual distances. It says on a map the distance between 2 cities is 2.5 inches and the actual distance is 150 miles. What is the actual distance between 2 cities which are 1.75 inches apart on the map? Well, let's look at this first sentence here. We know that 2.5 inches corresponds to 150 miles. I'm going to write that down. 2.5 inches corresponds to 150 miles. Now, we're trying to say at this rate, what is the actual distance between 2 cities, which are 1.75 inches apart? Notice how I'm lining up the inches, and I'm trying to determine the number of miles. Now it's time to do a little cross multiplication or simplification. I don't really like these decimals. I'd like to have a way to simplify it before I even start. Personally, what I would do is maybe multiply by 10 over 10 in this first fraction to be able to reduce after that, so I don't have that decimal any longer. But another choice, instead of multiplying by 10 over 10, is just to multiply by 2, because that's a 2.5 or 2.5 times 2, and that will work pretty easily. If I do that, I now have 5 inches in my numerator divided by 300 miles, and that can actually be reduced to 1 over 60. So 1 inch corresponds with 60 miles, is now equal to the 1.75 inches over x miles. And now we can do some cross multiplication. It's kind of nice that we have 1x on one diagonal. And then all we need to do is find out what 60 times 1.75 is going to equal. So here we go over to our scratch paper, 1.75 times 60. Because the units column has a 0 in it, I'm going to put a placeholder down. And then I'm going to begin my multiplication. 6 times 5 is 30, put the 0 down, carry the 3. 6 times 7 is 42, plus that 3 is 45, put the 5 down, carry the 4. 6 times 1 is 6, plus that 4 is 10. In our original problem, there are 2 digits to the right of the decimal, so I'm going to make sure in my answer we have 2 digits to the right of the decimal, and the answer is that the two cities are 105 miles apart. We're looking for X miles in this problem.